Welcome. This video is for CIE AS level 9709 statistics paper 1 practice paper 2. We are done practice paper 1. Now this is practice paper 2. Now a summary of 20 values of X has been given and summary of 25 values has been given. Find the mean for all the 45 values. So I'm going to find it out mean for all 45 values. So for all 45 will be sigma x minus 30 values plus sigma x minus 30 values for 25. Add them both and then divide by 20 plus 25. Then what am I going to do? This is going to be 439 and this is going to be 470 divided by 45, but this is the coded mean. To get back the original mean, it was minus 30, so add plus 30 to get back the original mean. So when you simplify that, you should be able to get 50.2 as the answer. Find the standard deviation. In the coding, what happens is the standard deviation does not changes. So standard deviation is going to be the same formula. Sigma x minus 30 whole square for the first 25 values, and for the next 20 values also we are going to add them up, but this time I'm going to divide with 45 minus coded mean. So what was the mean? The mean was nothing but what? This was the coded mean. This was the mean for the coding one, so that you have to get it out over here. So which becomes 909 divided by 45 whole square. So that care has to be taken over there. Simplify that, you should be getting it out 10 square root of 119.9. That's the answer. Question number 2. Now this question number 2 is what? From the probability. Now in this one, what is he telling? That Sam is a member of a soccer club. Is a member of a soccer club, and let's read that question carefully over there. She is practicing scoring goals. The probability that Sam will score a goal on any attempt is 0.7. So probability of success is going to be nothing but what? 0.7. So failure is going to be 0.3. Independent of all other attempts, she makes 10 attempts at scoring goals. So n equals to nothing but how much? 10. Find the probability that she will score fewer than 8. Fewer than 8 means it should be 0, 1, 2, 3, so on till 7, which is very difficult to add. So what I do? 1 minus 8, 9 and 10. 1 minus 8, 9 and 10. So it's going to be 1 minus 10C0, 0.7 whole to the power of 8, 0.3 whole square. 10C8, not 10C0, 10C8, 10C9, 0.7 whole to the power of 9, 0.3 whole to the power of 1, 10C10, 0.7 whole to the power of 10, 0.3 whole to the power of 0. So it becomes 1 minus 0.2335 minus 0.1211 minus 0.0282, which is going to giving me 0.167. Let's come to part B. Find the probability that Sam's first successful attempt will be before the fourth attempt. So first attempt, or first attempt and second attempt, or first attempt, second attempt and third attempt, or first, second, third and fourth. So she passes over here, does not pass and a fail, pass, fail, fail and a pass, fail, fail, fail and a pass. So this is going to be 0.7 plus 0.3 times 0.7. This will be plus again 0.3 times 0.3 times 0.7 plus this is again 0.3 times 0.3 times 0.3 times 0.7. Simplify this. This should be giving you the answer as 0.9919. That's going to be the answer. Now coming to the next part of the question. Wei is a member of the same soccer club. He is practicing the scoring goals. The probability that Wei will score a goal on any attempt is 0.6. So his scoring a goal is going to be 0.6. Not scoring a goal will be 0.4. Wei is going to keep making attempts until he scores 3 goals. Until he scores 3 goals. Find the probability that his third goal is on the 7th attempt. Third goal is on the 7th attempt. So 1, 2, 3, 4, 5, 6, 7. Over here he is scoring a goal, so which is 0.6. But this is the third goal. So therefore 2 more goals. 2 more goals. 2 more goals have to be selected in these 6 places. So 6C2. So maybe over here goal and a goal. 6C2. So for this one is going to be nothing but what? 0.6. So 0.6 and 0.6. Then remaining 4 places, or what is this 4 places? No goals. No goal over here, no goal, which is no goal, no goal, no goal, and no goal. So how many times is that? What is this? 4 times. So 0.4. So this is 0.4, this is 0.4, this is 0.4, this is 0.4. 0.4 is how many times? 4 times. 0.6 is 2 times, and one more 0.6 is there, which is the third time. So you can see the arrow marks over here. This is for this 0.4, this 0.4, this 0.4, and finally this 0.4 will make up over here. Then this 0.6 is over here, and this 0.6 is also over here. This 0.6, but this 0.6 is over here. So simplify that, you should be getting 0.0829. Now question number 3. In this question number 3, it is from normal distribution. The keyword is going to be nothing but what? Normal distribution. So let's see that how is that normal distribution question is being done. So the weights of oranges can be modeled by normal distribution with a mean 131. So mean equals to 131 grams. Standard deviation equals to 54 grams. Oranges are classified as small, medium, and large. A large orange weighs at least 184 grams. So probability of x greater than 184 is going to be called as large, and 20% are called as small. Probability of x less than small equals to nothing but what? 20%. Find the percentage of oranges that are large. So which percentage is that he's asking? So probability of converting to z greater than 184 minus 131 divided by 54, which is going to be probability of z greater than 0.9815. Whenever greater than, you do 1 minus probability of z less than 0.9815. So 1 minus 0.837, which is 0.163. But I want percentage, so 0.163 times 100, which is nothing but what? 16.3%. Find the greatest possible weight of the small one. So probability of x less than small equals to nothing but what? 20%. So probability of z less than s minus 131 divided by 54 equals to 0.2. But this 0.2 is not there in the table. If at all it is not there in the table, what am I going to do? Subtract from 1, so it will become 0.8, and swap this. So probability of z less than 131 minus s by 54 equals to 0.8. Look from the table, 131 minus s upon 54 equals to 0.842. So 131 minus s equals to 54 times 0.842. So s equals to 131 minus 54 times 0.842. This should be giving me the answer as 85.5. Now coming to question number 4. Question number 4 is from stem and leaf. Back to back stem and leaf diagram we have to draw, and then we have to solve it from there. So for that, let's read the question carefully. Time taken in seconds by 15 members. How many members are there? 15 members by 2 swimming clubs, penguins and dolphins. 50 meters is shown. Draw the back-to-back stem and leaf diagram. So I am drawing the back-to-back stem and leaf diagram. So it's going to be, first draw the stem. The stem makes up of 30s, 40s, 50s, 60s and 70s. 3, 4, 5, 6 and 7. Then I write over here penguins. Then I write over here dolphins. Then the numbers, if you check, as such I have already done. I am directly writing it out over there. 2, 4, 5, 5 and 8, 0, 6, 8 and 9, 1, 6 and 8 and 72. For dolphins it's going to be 6, 1, 3, 8, 9, 9, 0, 1, 4, 6, 6 and 0, 1, 4 and 71. Now don't forget to write the key. What is key? 2/4/1 means 42 seconds for penguins. 42 seconds for penguins and 41 seconds for dolphins. 42 seconds and 41 seconds. The diagram shows the box and whisker plot for the times taken by penguins. On the diagram, draw the box and whisker plot for the dolphins. For dolphins, we are going to calculate the Q2. As such, I have already calculated the Q2 is 51, Q1 is going to be 48, Q3 is going to be 60. How is that? So let's calculate over here. There are 15. So Q2 is going to be 15 plus 1 by 2, which is 8th term. Which is the 8th term? 1, 2, 3, 4, 5, 6, 7, 8. So therefore, 51 is going to be Q1. Now, 8th term is over here. So 7 terms are on your left hand side and 7 terms are on your right hand side. Now, the middle term, 7 plus 1 by 2, 4th term. 4th term is going to be the Q1. 1, 2, 3, 4, which is going to be 48, which is Q1. Now, same is the case, 7 plus 1 by 2, 4th term. 4th term from 8th term. So 4th term from 8th term. So 1, 2, 3, 4. So which is going to be 60. Q3 is going to be 60. So now plot that one. For dolphin, Q1 is at 48. So this gap is 5 and how many parts are there? 5. So each part is 1. So 48. 48 is going to be this line. Then Q2 is 51. 51 is this line. Then 60. 60 is this line. So this is going to be the box, whereas the minimum value, you can see that minimum value is 36 and maximum value is 71. So draw a whisker till 71 and 36. 36. This is going to be for dolphins. So don't forget to write dolphins. Hence state one difference between the distributions of the times for the penguins and the dolphins. So we can see that penguins are faster. Why penguins are faster? Because they are taking less time. Q1 is also less, Q2 is also less, Q3 is also almost less. Okay, same. So penguins are faster. Penguins are faster. Why? Q1 of penguin is smaller than Q1 of dolphins. This is for Q3 also. Q3 of penguins is smaller than Q3 of dolphins. Then question number 5. We go to question number 5. This question number 5 is for the probability that a driver passes through an advanced training is 0.3. The probability that a driver passes a training is 0.3. Then from there we take it and on any given attempt. So probability of success is 0.3. So failure is going to be 0.7. So I got 0.3 and 0.7. Then he's asking probability of x lies between 2 and 6. So, and he tries until he takes he taking the test until he passes. Random variable x denotes the number of attempts requires for Deepak to pass the test. So it is find probability of x lies between 2 to 6. So he's asking us to between 2 to 6. What is that 2 to 6? 2, 3, 4, 5, 6. I'm doing a longer procedure. What is that one? Second time he's passing means first time failed and second time he passes. Third time he passes. So first two times he failed and third time he passed. Fourth time passed. First three times he failed and fourth time he passed. Fifth time passing. Four times he failed and fifth time he passed. Then five times he failed and sixth time he passed. So this is first time and second time. This is 1, 2 and the third time. This is 1, 2, 3 times fail and the fourth time. 1, 2, 3, 4 times fail and the fifth time. 1, 2, 3, 4 times fail and 5 times failed and the sixth time. So that's going to be the way. So simplify this one by calculator. You should be getting 0.582. Now expected value, remember expected value is going to be the way formula. So 1 upon P. So 1 upon 0.3, which is nothing but what 10 by 3, which is 3 1 upon 3. For geometric distribution, the formula is expected value is 1 upon P. 5 friends will take their advanced driving test tomorrow. Find the probability that at least 3 of them will pass tomorrow. So probability of 3, 4, 5. At least 3 of them will be passing tomorrow. So for that, what should I be doing it out? Taking the probability of 3, probability of 4 and probability of 5. 3, 4 and 5. So for that, what should I do? I will be doing probability of 3 and probability of 4 and probability of 5. So out of 5, 5C3, 0.3 whole to the power of 3, 0.7 whole to the power of 2. Then 5C4, 0.3 whole to the power of 4, 0.7 whole to the power of 1. 5C5, 0.3 whole to the power of 5, 0.7 whole to the power of 0, 0.1323, 0.02835, 0.00243. Then add them up, it becomes 0.163. Coming to part B, part C, 75 people. So N equals to nothing but how much? 75. Take a driving test next week. Use an approximation, the probability that more than x greater than 20 will pass the test. So passing is 0.3, failure is going to be 0.7. So mean is NP, which is 75 times 0.3, which is 22.5. Standard deviation is square root of NPQ, which is square root of 75 times 0.3 times 0.7, which is square root of 15.75. Now it is greater than 20. What does it mean greater than 20? If at all it is 20, then 20.1, 20.2, 20.3, 20.4, 20.5 and 20.6. Now if at all I take 20.1, it will be rounded off to 20. 20.2 is also rounded off to 20. 20.3 is also rounded off to 20. 20.4 is rounded off to 20. But 20.5 is rounded off to 21. So I'll be taking probability of z greater than 20.5 minus 22.5 divided by square root of 15.75. So this is probability of z greater than negative 0.504. So I want to convert negative to positive. So 1 minus probability of z greater than 0.504. I want to convert greater to lesser than 1 minus probability of z less than 0.504. So 1 minus 1 plus probability of z less than 0.504. This value is going to be 0.693. Now coming to question number 6. Question number 6 is from a concept of tree diagrams. So He's telling that Freddy has two bags of marbles. How many bags of marbles does he have? He has two bags of marbles. And the composition of marbles, bag A and bag B are being given. There is a bag A and bag B. Bag A has how many red? It has 7 red, whereas bag B has 4 red. Bag A has 3 blue, bag B has 1 blue. Freddy chooses one bag at random. So he will choose one bag at random. So it can be a bag A or a bag B. Bag A and a bag B, probability is 1 upon 2 and 1 upon 2. Instead of bag A and B, it has been given as X and Y. So I will write it as X and Y. Does not make any difference over there. So I will be writing bag X and Y. Bag X and bag Y. X and Y. Now what is it telling? A marble is removed at random from the bag and not replaced. So I am removing one marble from bag X, and also I will be removing one marble from bag Y. So it can be a red marble or it can be a blue marble. Red marble probability is 7 upon 10 and 3 upon 10, 4 upon 5 and 1 upon 5. It is not been replaced. Now it will become only 9 marbles. Now the new red marble is added. Now a new red marble is added. So what will be happening now? In this case, one red marble has been taken. So basically it will become 6 red and 3 blue, but again one is added, so it will become 7 red and 3 blue in this case. So the probability of red and the probability of blue. Probability of red will become now 7 upon 10 and blue will become 3 upon 10. Now if a blue marble is taken off, then it will become 7 red and 3 blue. But what will happen is 7 red and 2 blue. 7 red and 2 blue, but one red marble is added, so it will become 8 red and 2 blue. So in that case, over here, it is red marble and a blue marble. The probability is going to be 8 out of 10 and 2 out of 10. Now, if the red marble is taken away from the bag X was 4 and 1. So it becomes 3 red and 1 blue. But again, one red marble is added, so it will become 4. In that case, the probability, let me draw the two branches so that it is easy not to change the colors. So red marble and a blue marble. In that case, the probability of red marble is going to be 4 upon 5. Blue marble is 1 upon 5. In this case, it will become 4 red and 0 blue. But again, one red is added, so it will become 5. So what will be the probability over here? It will become 5 upon 5 and it will become 0. This is going to be the weight. So remember that in all these cases, one red is added. Now coming to part B. What is it telling? Find the probability that both the marbles from the bag are of same color. So we have to get it out both the same color, either blue and blue or red and red. So for that, what should I do? See that case, red and red. How can I get it out red and red? You can see that this is the probability of getting red and red, and this is the probability of getting blue and blue. And in case of bag Y, red and red, blue and blue is not possible. So in bag X, it is blue and red and red. In bag X, it can be blue and blue or red and red, or in bag Y, it can only be red and red. So in bag X, blue and blue will be 1 upon 2 times, 3 upon 10 times, 2 upon 10. Bag X again 1 upon 2 times, 7 upon 10 times, 7 upon 10. Bag Y, red is 4 upon 5 times, 4 upon 5. Blue and blue is not possible in bag Y. So which is going to be 6 upon 200 plus 49 upon 200 plus 16 upon 50, which is going to be 0.03 plus 0.245 plus 0.32. So simplify that, you should be getting it out 0.595. If you want to write in fraction, 119 by 200. Now coming to part C. So find the probability that bag Y is chosen given that the bag marbles removed are not both the same color. So probability of bag Y and different colors. They are of different colors, means probability of bag Y and different colors divided by probability of different colors. Probability of same colors, we got it out. So probability of different colors will be 1 minus this one. 1 minus 119 by 200 is going to be probability of different colors. Probability of Y and different colors. So Y, it is a red and it is blue, or Y, it should be a blue and it should be a red. This is Y, red and blue. Y, blue and red. So simplify that, you should be able to get 9 upon 50 divided by 81 upon 200, which is going to be 4 upon 9. If you want to write in decimal, 0.444 is going to be the answer. Now finally question number 7. Now question number 7, how many different arrangements of the words letter intellect? So intellect is the word. How many different arrangements of this word letter intellect? Intellect can be done if two T's are together. So there are two T's together. So let's write. What am I going to write it out? I am going to write it out. Intellect. Intellect. Two T's are together. So Innellec. So how many units are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 units can be arranged in 8 factorial divided by 2 factorial, 2 factorial. Why this 2 factorial? 2 e's. Why this 2 factorial? 2 l's. So this is going to be 110,080. How many different arrangements are there for the 9 letters words in the intellect in which there is a T at each end and 2 e's are not next to each other? So what am I going to do? E's are not next to each other. So simple method is I'm going to do number of ways with no restrictions for E. No restrictions for E minus number of ways with E's together will become E's not together. So what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So T is at the beginning, T is at the ending. So T is gone, T is gone. So how many are left over? 7 places. 7 places, 7 alphabets. 7 places, 7 alphabets can be done in 7 factorial divided by 2 factorial, 2 factorial. Why is it so? For E's and L's. Then minus the number of ways E's are together. So what does that becomes? For E's are together, let's move this one neatly so that I can give the space. This entire thing is for this. Then over here, then I move it out over here. This is that minus. Then E's are together. 1, 2, 3, 4, 5, 6, 7, 8, 9. So T is at the start, T is at the ending. So 7 more alphabets. But what is this? Those two E's are over. Then I'm left over with nothing but what? INLLC. So how many units are this one? These are 1, 2, 3, 4, 5, 6. 6 units can be done in 6 factorial divided by 2 factorial. This 2 factorial is for L. So minus 7 factorial by this one. So this is 1260 minus 360. So answer is going to be 900. Then finally, 4 letters are selected at random from the word intellect. Find the percentage of possible selections which contains at least one E and one T. So it should have a T and E for two more, or one T and two E's and one more. So in that case, intellect, we can see that E's are over and T is over. So how many I'm left over with? Nothing but what? So, and one T and one E. So how many are left over now? One, 2, 3, 4. Else are same, 5. Out of 5, this can be filled in nothing but what? 2 places, 5C2. But this T can be selected in 2C1. 2 T's are there. This E can be selected in how many ways? 2C1. So let me write it out here like this. So I move it down so that it is easy to write. So this T can be selected in 2C1. This E can be selected in 2C1. This can be selected in 5C2. So this is going to be 40. Then for this one, this T can be selected in 2C1. This 2 can be selected in 2C2, whereas this can be selected in 5C1. So this becomes 10. So total is going to be 50. But he's asking percentage. So 50 divided by total out of 9, I have to select 4 times 100. So which is 50 upon 126 times 100, which is going to be 39.7%.